Hello guys, welcome to Bhairam channel. Today we'll be trying to understand the importance of topic called thermodynamics. Why thermodynamics is very essential and what exactly is thermodynamics? How does this thermodynamics differ from other topics? We will try to analyze and understand each and every point of thermodynamics. In this video, I'll be trying to helping you to understand the definition and some of the basic terminologies of thermodynamics. What is thermodynamics and how this thermodynamics is important? See, when you compare thermodynamics with any other branch of chemistry like atomic structure or basically any other part, thermodynamics is something which is very different from all those science topics as well as concepts. Thermodynamics basically talks about the energy. Thermodynamics basically talks about energy exchange between system and surrounding. Before going to understand the basic science of thermodynamics, the first thing what I'm gonna tell you people is that this thermodynamic is something called fact-based logically deduced science. Logically deduced science. Now, when I write science, you people have to understand, you see. In science, we have two basic parts. One is a theory part and another is a practical part. When we talk about theory part, a theory is never called as a fact. Remember this. A theory is never called as a fact. Once theory is known to be fact, then we don't name it as a theory. It will become fact. Now, what is the basic difference between fact and a theory? See, fact is something which is true at all point of time, and there is no contradiction to it. Now, when I say theory, in some point of time, like we have a lot of theories, like you see Schrodinger's wave theory. We have a lot of theories. If at some point of time, if some fellow comes up with a disadvantage or a limitation of that theory, then the whole theory fails. Now, what is the fact? Fact is something which cannot fail. Now, this thermodynamics is a fact. Okay, so this is where it stands unique when compared to all the other branches of chemistry. So, thermodynamics is very like fact. You will study the same. Your next generation will also study the same things, and next another 4 generations also are about to study the same things. If they take science as their subject, they will study the same thermodynamics. Why is it so? Because it's fact, so it doesn't change with time. Whereas other topics of chemistry may change because they are theory. Please do remember this, and this is what it makes thermodynamics very unique and very important. Now, we will try to understand more about thermodynamics. First of all, why we should study? What is the aim of studying thermodynamics? See, aim of studying thermodynamics is to understand and to appreciate about a chemical reaction without performing it. Yes, you are right. So you should, this thermodynamics will help you to predict whether a given reaction occurs or not. When I say occurs, it means spontaneous. What do you mean by the word spontaneity? Spontaneity is a reaction. Spontaneous reactions are the reactions which takes place in nature without any external aid. Just like water falling from the top of the hill. Water falls from the top of the hill. You need not go there and push it down, right? So water just falls from the top of the hill. So that is a spontaneous process. So this thermodynamics will help us to identify the spontaneous process. Now, what is the use of understanding spontaneous processes? Always remember, whenever you have a spontaneous reaction going on in nature, it produces a lot of energy. That energy can be utilized to do the external work. So, thermodynamics basically helps us to classify the reactions into two types. One is spontaneous one, whereas another is non-spontaneous one. So, how to identify which reaction is spontaneous? How to identify which reaction is non-spontaneous? All these things comes under thermodynamics. Now, we will try to understand the main meaning of thermodynamics. Now, thermos is something to do with heat. Dynamics means flow. See, you should understand thermodynamics will help us to keep the record of the energy inflow and outflow, or energy exchange between the system and the surrounding. So, basically it was supposed to be exchange of heat between the system and the surrounding, but later, as we started to understand the concept of energy more and more, the scope of this meaning has broadened. The definition of this term has been broadened. So today we understand that thermodynamics involves understanding and logically bookkeeping of energy exchange between system and surrounding. Now we will try to understand more about thermodynamics. As I have already told you, this thermodynamics has everything to do with energy, right? So before going to talk more about thermodynamics, let me try to help you to understand a little bit of terms which are in thermodynamics. The first term that I'm going to talk about is a system. Now, what is a system? What is a system? System is anywhere or anything which is subjected to thermodynamical study. Are you getting my point? So, most of the time, this system may have a boundary, a physical barrier, and may not have the physical barrier. That doesn't form the criteria. But system is a part of the world or part of the universe in which thermodynamical study is carried out. So it's a place. It's a part of the universe where thermodynamic study is carried out. So so another important point in this system is, as I have already told you, it may or may not have a physical boundary. Now, system basically can be classified into three different types. Let me try to help you to understand that. So there are three basic categories of system. So the first one among them is called open system. Now, what is an open system? Let us assume a beaker containing water, and let us assume that you are heating that beaker containing water and there is no lid on it. Now, what will be happening over there? So once the temperature reaches about say 100 degrees Celsius, if you still keep on heating, water will start evaporating. See, in such kind of system, both matter as well as energy gets exchanged between system and surrounding. So what are open system? Open system are the system wherein which both matter and energy gets exchanged between system and surrounding. I've given you a best example. The best example is heating water in a beaker. When you heat water in a beaker, your water will get evaporated. In that process, both matter, which is nothing but water vapor, as well as energy of the system will get exchanged with the surrounding. Now, in the case of closed system, In the case of closed system, now let us go back to the same example. So you have a beaker and you have water and you are heating water. Now, if you put a lid on that beaker, what will happen? When you put a lid on that beaker, water will not escape from the system, but energy will continue to get exchanged between system and surrounding. So that's the example for closed system. In closed system, only energy gets exchanged. Energy gets exchanged between system and surrounding. I hope you people are coping up with me. So in the open system, you had both energy and matter getting exchanged between system and surrounding, whereas in closed system, only your energy is getting exchanged between system and surrounding. By the way, I hope you people understand what is surrounding. I didn't try to define it. I hope you people know what is surrounding. It's nothing but immediate vicinity of the system. Immediate vicinity of the system is called as surrounding. And always remember, when you add up both system and surrounding, they are part of universe. So you please keep that in mind. So system is a part of the universe. Surrounding is also a part of the universe. And what is system? System is a place where thermodynamical study take place, and surrounding is immediate vicinity of the system, wherein which the exchange of heat, energy, or whatever you say takes place. Now coming back, especially energy, which is in the form of heat and matter, exchange takes place between system and surrounding. Please keep this in your mind. Now coming back, now what is isolated system? Isolated systems are the systems. Now before going to isolated system, let me give you an example. Best example for the isolated system is thermos. See, in your thermos, if you pour a hot cup of coffee, it will try to retain the hotness of the coffee and to the maximum possible extent of time, right? But always remember, there is no perfectly isolated system. If you try to create isolated system which can retain its temperature for long amount of time, you may end up getting Nobel Prize. So if you have any dream of getting Nobel Prize, this is the area wherein which you can work. Now coming back, so isolated system is a type of system where neither matter nor energy is exchanged between system and surrounding. For more such exciting and study related videos, please subscribe and support Bhairavan channel. Thank you.